In this video, we're going to talk about the 30, 60, 90 degree triangle. First question, if a 30, 60, 90 degree triangle has a smallest side of length 2, then what is the length of the hypotenuse? So here we've got a 30, 60, 90 degree triangle, its smallest side is length 2, and we want to figure out what is the length of the hypotenuse. Now this might look kind of difficult at first, but there's an insight which makes this problem extremely easy. And that is to notice that this 30, 60, 90 degree triangle is just half of an equilateral triangle. To give the full picture, let's actually draw in that equilateral triangle. So we'll double this side, go up until 8, and then have it connect to the top here. Alright. So first of all, the way we know that this is an equilateral triangle is by symmetry. This dotted triangle here is just the mirror image of this solid triangle, so it has to have the same angles. This is also a right angle, but more importantly, this here is also a 60 degree angle, and this here is also a 30 degree angle. Put these 30 degree angles together, you've got a 60 degree angle, a 60 degree angle, a 60 degree angle. All the angles are equal, which means all the sides are equal. Now, because this triangle here, the dotted triangle, is the mirror image of this solid triangle, the side lengths are also the same. So this base here of 2 mirrors this base of 2 as well. So altogether, the base of the equilateral triangle is 4. And the base has to be the same as the side lengths because it's equilateral. So these sides are also 4. So there we go. There is the length of the hypotenuse. It's 4. Now before we move on, why don't we generalize this argument so that we don't have to draw out the picture every single time to figure out what this hypotenuse length is. Let's draw another 30, 60, 90 triangle. So here we've got the base, then we'll make the right angle, and then we'll connect to the hypotenuse here. So this is 30 degrees, 60 degrees, and 90 degrees. And why don't we label the smallest side length as x? Now if we proceed the same way and mirror this triangle on the other side, let's go ahead and draw that in. So duplicate the base and also have it go up, make another hypotenuse. We've again got an equilateral triangle, since the angles 30 and 30 add up to 60, and we've also got a 60 degree angle here. And the base of this mirrored triangle is the same, it's also x. And since this overall big triangle is an equilateral triangle, all the sides have the same length, so this side here is 2x, just x plus x, so this side also has to be 2x, and so does the other side. So basically, if you know the smallest side of a 30, 60, 90 degree triangle, and you want to find the hypotenuse, all you have to do is double it. And just as a sanity check, this matches up perfectly with our first example. 2 times 2 makes 4. You double 2, you get 4. Here's another example. If a 30, 60, 90 degree triangle has a hypotenuse of length 8, then what are the lengths of the legs? So here we've got a hypotenuse of length 8 in a 30, 60, 90 triangle, and we want to find these side lengths of the legs. Now remember, we saw before that if the smallest side of a 30, 60, 90 degree triangle is x, then the length of the hypotenuse is 2x. You just double it. So we can use that fact to figure out one of these legs. So to get the length of the shortest leg here, we just have to think what doubled makes 8. And to find that, we can just divide 8 by 2. Half of 8 is just 4. 4 doubled makes 8, so that's the length of the shortest leg. Alright, but we also want to find the length of this other leg. So how do we find that? Well, now that we know two sides of the triangle, and since this is a right triangle, we can use the Pythagorean Theorem. So why don't we label this middle-sized leg as b, so it'll be like ABC, and then we can set up the Pythagorean Theorem. That just states that the hypotenuse squared, so 8 squared, is equal to the sum of the legs squared. So equals 4 squared plus b squared. And we can simplify that. 8 squared is just 64. That's equal to 4 squared is 16. So 16 plus b squared. Now to solve for b squared, we can start off by subtracting 16 to get b squared alone. So subtract 16 from both sides. Minus 16 minus 16. 64 minus 16 is 48. So 48 is equal to b squared. And now to get the square off of the b, we can just take the square root of both sides. We have b, and on the left-hand side, we have square root of 48. And notice that 48 is just 16 times 3, so we can write this as root 16 times root 3, which simplifies. Root 16 is just 4, so 4 root 3, that's what b is. So there we have it. 4 root 3 is what b is. B equals 4 root 3, and we've got all the lengths of the legs. There's 4 and 4 root 3, given the hypotenuse of 8. Again, why don't we generalize this situation so that we don't have to go through this work every single time? We already know that if we have a 30, 60, 90 triangle with shortest side of length x, then the hypotenuse has to be double that. It has to be 2x. So using that information, we can figure out what b is. So what does b equal? Well, we'll just use the same process that we did in this example. So on the right-hand side, the Pythagorean Theorem. So take the hypotenuse, 2x, square it, and that's equal to the sum of squares of the legs. So equals x squared plus b squared. Now we can just go ahead and solve for b. So 2x squared. 2 squared is 4, and then we have x squared, and that's equal to x squared plus b squared. So let's just go ahead and subtract x squared from both sides, get that b squared alone, and the result is 4x squared minus x squared is 3x squared. So 3x squared equals b squared. Now we can just go ahead and take square root of both sides to get the square off of the b. So on the right hand side, we've just got b. On the left hand side, we can pull out that x squared, just make that square root of x squared times square root of 3, and square root of x squared is just x. So x root 3 is what b is. So there we go, x root 3, b equals x root 3. This matches up perfectly with what we found in the example. When the shortest side was 4, the middle side was 4 root 3. Perfect. Alright, so now let's apply what we've learned to solve a bit of a trickier problem. If the perimeter of a 30, 60, 90 degree triangle is 4, then what are the side lengths of the triangle? Well, remember that in a 30, 60, 90 degree triangle, if the shortest side has length x, then the hypotenuse is double that, 2x, and the other side, the middle side, is x root 3. Now we know that the perimeter has to be 4, so we can start out with that. Perimeter equals 4, and then for the perimeter, we can just add up these side lengths in terms of x. Then we'll have an equation that we can use to solve for x. So let's go ahead and write that up. Perimeter is shortest side, x, plus the middle side, so plus x root 3, then plus the longest side, the hypotenuse, which is 2x. And that's gotta equal 4. So let's go ahead and solve for x here. First of all, we can combine this x and this 2x and make 3x. So get 3x plus x root 3 equals 4. And now we can factor out an x out of both of these terms. X times 3 makes 3x, and x times root 3 makes x root 3. So x times the quantity 3 plus root 3 has to equal 4. Which means to get x, all we have to do is divide by that quantity 3 plus root 3. So x equals 4 over 3 plus root 3. Now we usually don't like to write expressions with radicals in the denominator, so let's go ahead and rationalize this expression. To do that, all we have to do is multiply by the conjugate of that radical expression. So instead of 3 plus root 3, we'll be multiplying by 3 minus root 3. but we don't actually want to change the fraction. So we multiply by 3 minus root 3 over 3 minus root 3, so it's just like we're multiplying by 1. Okay, so let's go ahead and multiply this. X equals, let's multiply the top. 4 times 3 is 12, and then 4 times negative root 3 is negative 4 root 3. Alright, let's go ahead and multiply the bottom. This will multiply to a perfect difference of squares. 3 times 3 makes 9, and then 3 times negative root 3 and root 3 times 3, those will cancel out, and then we'll just have minus root 3 times root 3, so minus 3. Now we just need to simplify. So x equals 12 minus 4 root 3 over 6, which is equal to 12 over 6 is just 2, and then minus 4 over 6 root 3. 4/6 we can just divide by 2 on top and bottom, get 2/3 root 3. So that's the value of x. X is equal to 2 minus 2/3 root 3. Then we have the middle side here. We need x root 3 for the middle side. So that's just 2 minus 2/3 root 3 times root 3, which is just 2 root 3, then minus 2/3 root 3 times root 3, so minus 2/3 times root 3 is just 3, so minus 2/3 times 3, and then this 3 and the over 3 will cancel, and we just have 2 root 3 minus 2. And there we go, that is the length of the middle side. That's just 2 root 3 minus 2. Now let's get the hypotenuse. The hypotenuse is just 2x, and that's a bit easier. We already know what x is, so 2 times 2 minus 2/3 root 3. Just multiply through by 2, and you get 4 minus 4/3 root 3. So that's the hypotenuse, 4 minus 4/3 root 3. So we can finally write our final answer. The side lengths are as follows. We've got the shortest side, 2 minus 2/3 root 3. Then we've got the middle side, 2 root 3 minus 2. And then we've got the largest side, the hypotenuse, which is 4 minus 4/3 root 3. And there we go. These are the side lengths of the triangle. Now we know how to quickly find side lengths in a 30, 60, 90 triangle. This will prove very useful to us when we work with triangles in the future, because it'll save a lot of time on calculations.